Okay, today we're going to look at section 1.7, talking about linear compound and absolute value inequalities. So a linear inequality is any relation in the form ax plus b is less than 0, or ax plus b is less than or equal to 0, or ax plus b is greater than 0, or ax plus b is greater than or equal to 0. There are some properties of inequalities. If we let a, b, and c represent real numbers, if x is less than a, then a is greater than x. If b is less than b, if a is less than b and b is less than c, then a is less than c. If a is less than b and c is less than d, then a plus c is less than b plus d. If a is less than c, then a plus c is less than b plus c, and a minus c is less than b minus c. And if c is positive and a is less than b, then ac less than bc, a over c less than b over c. Now here's the tricky one here. If c is negative and a is less than b, then ac is greater than bc, or a divided by c is greater than bc. And these statements hold true for any of the other inequality symbols greater than, less than, equal to, or less, or greater than or equal to, should be. Okay, so I want to look at number 6 here real quick, because it seems kind of counterintuitive. And then we'll do some examples and go from there. So I'm going to say 4 is less than 6, right? I think we all agree with that. So what we're saying is multiply by some number c. So I'm going to multiply both sides by -1. And is that true still? Well, this becomes -4. Oops. And this becomes -6. So no, it changes. So when you multiply or divide by a negative, do not forget to reverse the direction of the sign. So let's go to some examples of this. And we'll start off with skill practice 1. Solve the inequality, graph the solution set, and write the solution set in set builder notation. Now we haven't talked about that yet, so we'll talk about that as we do it. So the equation is -5t minus 6 is greater than or equal to 24. So essentially, we solve this the same way. We have -5t add 6 is greater than or equal to 30. Now I'm going to divide both sides by -5. Gives me t, and this gives me -6. And don't forget, I divided by -5 to change the sign. So in this case, t is less than or equal to -6. So graph the solution set. Graphing it means a line. So here's 0, here's -6. Now, there's two ways to do this. We can either use a dot to signify that -6 is part of the solution because there's an equal, or like that, less than or equal to -6. We can also use the bracket. I think the bracket is probably the more logical way to go, and you'll see why in just a moment. So, set builder. This is graph. Set builder notation. Well, if it's a set, have a set. We have a variable. Not that difficult to do. And what this means is the set of all t's, all right, that's this part, this is such that, that's what the colon means in this case. And then t is less than or equal to 6. That's all that translates to. And then, of course, we go back to interval notation. My leftmost value is negative infinity. And you may remember infinity and negative infinity are never included, so we use a parentheses. My highest number included is negative 6, and it is included, so we use a bracket. Now this is set builder, and this is interval. Interval notation. And that's the 3 possible ways to give our solution. Okay, let's look at another one, a little more complex. You'll practice 2. We have m minus 4 over 2 minus 3m plus 4 over 10 is greater than negative 3m over 5. So first we need to find the least common denominator, and you'll see that it's 10. We multiply everything through by 10, and we get 5 times m minus 4 minus 3n plus 4. This minus distributes to both of them. Be careful there. And this becomes minus 2 times 3m. Go ahead and do our distributing. We have 5m minus 4. These are all m's, not n's, which makes more sense. Negative 3m minus 4 greater than negative 6m. So let's do some combining over here on the left first. We got negative 3m and 5m, so I have 2m. Negative 4, negative 8 greater than negative 6m. If I go ahead and add 6m to both sides, I'm adding, so I don't have to change the sign. 8m minus 8 greater than 0. Again, I'm adding 8 to both sides. 8m greater than 8. M is greater than 1. And I divided by a positive, so the sign stays the same. So now looking at my graphing, I have my 1. There's no equal sign here, so I use a bracket, and I'm going greater than. Set builder, well, I have the set of all m such that m is greater than 1. And then interval, I'm starting at 1. It's not included, so I use parentheses. Going to infinity, which is always parentheses. So that's the basics. So let's look at the next thing on here. Solving a compound inequality. To solve a compound inequality, first solve the individual inequalities. If the two inequalities are joined by the word and, the solutions of the variables that simultaneously satisfy each inequality, or the solution is the variable that simultaneously sign each inequality. As we take the intersection of the individual solution sets. If we have and, that means both of them have to be true, so it's the intersect. The two inequalities are joined by the word or. The solutions are the value of the variable that satisfies either inequality. Therefore, we take the union. So let's look at an example of this. About skill practice 3. Solve 1/4 y is less than negative 1, or 3 plus y is greater than or equal to 5. So we solve these individually. Here I'm going to multiply by 4, which is positive, so my sign stays the same. 3 plus y. So here I'm going to subtract 3. So my sign stays the same because it's subtraction. So y is less than -4 or y is greater than or equal to 2. So let's graph these. Well, let's graph these like this. -4, 0, 2. This says y is less than -4. That's this. And this says y is greater than or equal to 2. That's this. Since we have an or, it's the union. So we just put both of them on the same graph. Okay. And we could write this set builder, set of all y such that y is less than -4 or y is greater than or equal to 2. We could do interval -infinity to -4 union with 2 to infinity. So let's do an and. Skill practice 4. We have 0.36W less than or equal to 0.54 and -1/2 W is greater than 3. So here, if I divide by 0.36, W is less than or equal to 1.5. Here, if I multiply by -2, W is less than -6. Now this is an and, so it's the intersection. So let's look at the graph of this. Start with, well, there's 0, there's our 1.5, there's our -6. So looking here, I have 1.5, and it's saying less than or equal to 1.5, so I have a bracket, and I'm going here. Here, I have less than -6, so I have parentheses and less. Since it's and, it's the intersection, which is this. So we're looking at a final solution as a set of all W such that W is less than -6 or -infinity to -6, neither included. Okay. Now looking at skill practice 5, you have something a little different, -16 less than or equal to -3y minus 4 less than or equal to, or less than 3, or less than 2. Okay. So now all we do is we work this all together at once. So I need to get my y by itself. First, I'm going to add 4 to both all sides. So this becomes -12 less than or equal to -3y less than 6. Then I'm going to divide by -3. I'm going to get 4 here, y here, and -2 here. I'm going to change the directions of my sign. Okay. Now this is essentially an and. Composite inequality. First thing to note is the signs are facing the same direction. So let's look at how this works. And the signs are facing less than. So let's look at this and see what we get. Our points of interest are -2, and we always want to put a 0 in there and 4. Now here, this is saying greater than or less. It's saying y is less than or equal to -4. So I have my equal and I have my less than. And here it's saying y is greater than -2. And those intersect. I can't include -2 because it's not included in the lower one here. But I can include 4, and it's this area here. That's how these work. Okay, so let's look at absolute value. Let's talk about this a minute first. Properties involving absolute value inequalities. For any real number k greater than 0, so positive, absolute value of u is less than k is equivalent to putting u between -k and k. So this would be an and. And that's why the previous problem was less than. Because if it's a greater than, you have to solve it as an or separately. And of course, these hold for all the other inequality symbols. So let's look at some examples of this. Where are we at? Number 6 here. Solve the inequality and write the solution set in interval notation. First, I have 3 times the absolute value of 5 minus x plus 2 is less than or equal to 14. First thing I want to do is isolate my absolute value. So subtract 2, so 3 times the absolute value of 5 minus x less than or equal to 12. Then divide both sides by 3. I have absolute value of 5 minus x. And I'm dividing by a positive. I'm good. So here I'm looking at less than or equal to. So that means I take this, take the negative of it, less than or equal to 5 minus x, less than or equal to 4. So now I subtract 5 from both sides. -9 less than or equal to -x less than or equal to -1. Then I multiply by -1 to get a positive x in the middle. 9 here, 1 here, and I change the direction of the sign. Now, the instructions say interval notation. And you may or may not be able to grasp it from here. I like to graph it no matter what. It makes it easier to see. Not saying you would have to, but it just makes it easier to see. So here I'm saying x is less than or equal to 9. So bracket less than or equal to 9. Here I'm saying x is greater than or equal to 1. Bracket greater than or equal. Those two intersect right here. So my interval notation, 1, 9, and brackets on both because they were equal. Solve the inequality and write the solution set in interval notation. It'll practice 7. So I have -18 is greater than -3 times the absolute value of 2y minus 4. So now I'm going to divide by -3, which gives me 6. Change the direction of the sign. Now this is backwards of what we're normally dealing with. So I could do this. 2y minus 4. Now note it's greater than, so I'm going this way. So this is greater than, which means it's going to be an or statement. So from the or statement, we have 2y minus 4 is less than -6, or 2y minus 4 is greater than 6. So add our 4 to both sides. 2y is less than -2. Y is less than -1. Or 2y is greater than 10. Y is greater than 5. Looking at my graph, -1, we have a 0, and we have our 5. This is saying less than -1, but not equal. That's this part here. This is saying greater than 5, but not equal. So that's our solution. Interval notation, -infinity to 1, not including 1, union with 5 to infinity, not including 5. Okay, let's look at skill practice. 8. And let's see about doing all of these or some of these. So we have a, which is absolute value of x minus 3 less than -2. So we have a variable on the left, we have a less than sign. That means it is an and statement. So that means we have the negative of -2, which is 2, less than or equal to x minus 3 less than -2. Okay. So remember, this is an and statement. So add 3 to both sides, I get 5 less than or equal to x less than or equal to 1. So what am I looking at? I'm looking at 5 is, or x is greater than 5 or equal to, that's this. And I'm looking at x is less than 1, that's this. And when are both of these true? They're not. So this is the empty set. Look at B here. We have x, absolute value of x minus 3 greater than -2. Did I just do that one? Opposite direction. So this is an or. So x minus 3 is less than 2, or x minus 3 is greater than -2. This is an or statement. All right. So let's look at, excuse me. So x is less than 5, or x is greater than, oops. Somewhere I messed up here. Let me see, where did we mess up? Let me pause this. Okay, I see where we're at. So here we have 5, here we have 1, here we have 0. Now we're saying absolute value of x is less than 5, or x is less than 5, not including. Then we're saying x is greater than 1, but it's an or statement, so it's an intersection. So it's all reals infinity to infinity. Oh, reals. And then C and D is just looking at the same thing. So we'll skip those and go on to number 9. Okay. For a recent year, monthly snowfall in inches for Chicago, Illinois for November, December, January, and February was 2, 8.4, 11.2, and 7.9 inches respectively. How much snow would be necessary in March for Chicago to exceed its monthly average snowfall 7.28 inches? So 5 months. Total amount of snowfall needed, 7.28 times the 5 months. So the need 36.4 inches. We have 2 plus 8.4 plus 11.2 plus 7.9. This is 29.5. So we're basically saying we want to exceed it, not equal it. So whatever we get in March plus what we already have has to be greater than 36.4 for this to work. So subtract 29.5 from both sides. 36.4 minus 29.5. We get x must be greater than 6.9 inches. And that's it. And one more to go, I believe. Skill practice 10. Okay, so a board is to be cut the length of 24 inches. The measurement error is no more than 0.02 inches. Let x represent the actual length of the board. Write an absolute value inequality that represents an interval in which to estimate x. So the actual length minus 24, I take the absolute value of that, it must be less than or equal to 0.02. That's A, that's our equation. And then we solve it. So for B, we have negative 0.02 less than or equal to x minus 24, less than or equal to 0.02. Add 24 to both sides, and this becomes 23.98. This becomes x, and this becomes 24.02. So we solve the inequality in part A and interpret the meaning. This means the board length must be between 23.98 inches and 24.02 inches. And that is it. That's it for this section. That's it for this chapter. That's it for this exam. So exam 1 should be coming up shortly. Have a good day. Don't forget to study. Try to stay caught up with your work. And I will see you soon.